In this section, we're going to talk about sealed classes. And sealed classes have been introduced into the JEP 409 and have been finalized in Java 17. And they allow an author of a class or interface to have more control about who implements or extends that class. And today we only have just a final default or a protected mechanism, and that's just not enough flexibility. And in the future, the Java authors want to have more control about or more flexibility on the compiler side when you introduce a switch statement, so that the compiler knows who can use the switch and you don't need a default anymore. But let's have a look at the issues today. And today, when you are writing in a Java environment, you only have a few options. So first of all, let's say we have an interface shape, and that shape you want to have a class triangle. And if you want to limit the shape to be only implemented by the triangle, you can do it because it's in the same package. So this shape can be implemented by this triangle because it's in the same package. But let's assume we introduce a new class called a square. And this square, if we want to implement the shape, then it's not allowed because shape is not recognized, and shape is only a part of this package, and so Java compiler prohibits you to do anything more than this. But besides that, there is no way of really handling this in Java, so you cannot limit it. And if I would, for example, throw this away, and if I would just create a new shape as an interface, and I make it public, then there is no way for me to limit it here. So I just import a class, I import the shape class, and that's basically it. So there's no way for a developer to limit who can implement your or extend from your interface or class. Okay, so in what cases would it be interesting to do this? And the first case that comes to mind that already is a limitation today is the when we look at an enumeration. So let's say we have an enumeration called planet, and this planet enumeration, I'm just gonna add it right here. It has Mercury, Venus, and Earth. And if we want to write a class test, and let me just make it a little bit bigger, the class test has a main method in here, and we want to have a switch, or let's just make this a public method. Public void is Mercury, and we pass in a planet P, and we could say okay, switch on P, and here it would create the default branches like this. And as you can see, there is no default branch necessary here. Okay, so usually in Java, when you write a switch statement, you have to write a default branch, but in this case this is not necessary because the enum planet has been limited to these three. So this is a case in Java where you can limit a class, or in this case enumeration, and then out of the box the compiler knows a lot more. Okay, so you can do these things, and the problem really in general is that Java always assumes that you extend from an interface. So when you define the interface shape, you can always extend from it, but you can never limit it. And this is where sealed classes and interface will provide a solution. So basically the issue today is there's no way to limit who can implement a class or interface. So let's have a look at sealed classes. And we're gonna go back to our example. I'm just gonna remove the square here and go back here and remove our interface shape and start from blank again. And let's just clean up this code a bit, and let's start from scratch and we first go for an abstract class called shape. And this abstract shape, we have a triangle and we have a square. So let's assume we want to implement or we want to say that only a triangle can be implemented. Then we can use the permits keyword. And the permits keyword automatically adds the sealed up front. So this is something IntelliJ does out of the box. And we say, okay, only a triangle can implement it. So in this case, only a triangle can implement it. And it also indicates that it has to be implemented. So in this case, we're going to extend from triangle. Okay, and we also have to mark it final, but this will come a bit later. So we have a final class extends from shape, of course, and this should suffice. Okay, if I'm gonna extend from shape here, this is not allowed because my shape right here is not allowed in the sealed hierarchy. This is what it says right here. So what you can see is that it forces you to implement or extend it, and when you do, it gives you an error. So I have to remove this here. Of course, these abstract sealed and permits, they're really annoying, and if you're just within one class, if you work within one class, then it's just sufficient to just avoid using the permits. So here you can just say we have a root, and this root is implemented by A, B, and C, but you can just say it's sealed, and these are the only implementations. So you don't think in practice this will be rarely used, but it can be of use. So in summary, a sealed class is a class with the permits keyword, and with the permits keyword right here, you have to specify who can extend from it. So that's the general principle of sealed classes, and these extensions also force you to do the implementation. So in this case, the shape permits triangle and square. We have triangle and square, and they have to be extended, otherwise the compiler will give a fault. Now there are a couple rules when you define a subclass, and mainly you have to specify who can extend that subclass. So the first keyword is the final keyword. When we use that, nobody else can extend from it. You can have a subclass, that's the second part, which can be sealed as well. So in this case, you can declare on a subclass who can extend from it. And the last one is a non-sealed subclass, which means that everybody else can extend from it. So let's go back to our example and let's have a look. So first of all, we said right here that it's final. So that means if I want to extend from triangle, then it's not allowed anymore because the class is final. However, if I'm going to write it's sealed, and I'm going to use permits right here, and I'm going to say squared. In this case, I will actually say, okay, I have to extend a triangle. Okay, and I have to oblige one of the three rules again. So I either have to mark it final, sealed again, or non-sealed. In this case, I'm just gonna say it's final. Okay, so this is really the simple case. But imagine you want to say, okay, I have this entire hierarchy, but when you're looking at a square, in the end, anybody can just extend from a square. So we're going to create a new class, class big square, and we're going to extend square. And in this case, it's not allowed because we marked it previous as a square, but now we're going to mark it as non-sealed. And non-sealed really breaks the ceiling, which means that anybody can again from everywhere just extend it. So big square extends square, and that's perfectly possible. Now let's have a look at sealed interfaces. And sealed interfaces really behave the same way as sealed classes. So let's just have a look and rewrite it. So we're just gonna remove the abstract right here. We have our sealed interface, which is a shape, and it permits triangle. And then we have the sealed class, which implements the shape. Okay, and we have the non-sealed square, which of course extends the triangle because this is a sealed. This is again a class, but we can do the same with an interface called another shape, and this extends the shape. Okay, but this is again not allowed because shape is sealed, so we have to specify another shape that is also part of the permits. And here we have to specify if it's sealed, non-sealed, or final, and we're just gonna say it's non-sealed, so anybody again can extend from it. Okay, so these are essentially the same rules that apply for a sealed interface as a sealed class, and you can pick or choose what's the most beneficial for you. Now with the sealing and non-sealing, the compiler is a bit smarter, and it uses this knowledge when you're writing an instance of. So let's go back to our example and just start again, and just remove what we had and replace it with a sealed interface shape, implements triangle, and a final triangle which implements shape, and we have a class square. So let's assume now I'm gonna write a test, class test, and in here I'm gonna write a main method, okay, like this, and I'm just gonna use a public void test method on shape, and whenever I write if shape instance of, and if I write now in teacher, or if I write square, the compiler will know that that it's not okay, because the compiler says right here, okay, in convertible types, it knows that the square or the shape in this case can never be of instance of square. Of course, when we go for a final class, in this case to a non-sealed, then it doesn't know it anymore, so the compiler check removes. But as long as you stay within a final or specific class hierarchy, it will actually show you how it works. Okay, so let's finish this and call it a final. We call this a triangle. This should be okay, and then it should return true, else it returns false. And now we could, if we just make this a boolean as a return type, now we can say return new test and dot test, and we call it new triangle, and this should return a true. So let's try this in action. It's not really compiling. Unexpected return type, it's a shape, and the shape implements a triangle, implements the shape, so that's okay. So let's see what it gives here. It needs return type. Okay, I'm just gonna replace this with an out statement, of course, like this, and this should work a lot better. Okay, so it's true. And if I would extend it, triangle, and just call it square, then of course I have to implement here the square, the shape, like this. It's also a final, and now it will still work. Let's try it again. Okay, so it's true, but if I pass in a square, new square, like this, it will return a false. Okay, and what they really want to do in the future with Java is that you can actually replace this with a switch statement to shape, and it would generate all of the instance of classes, and you could just say if it's this one, use this, if it's another one, use that. So let's see, this is not yet possible, but it's possible with a specific improvement which is coming in a later version. So if you're using sealed classes, the switch statements will become a lot easier. Now, because the sealed and the permits are two new things in Java, they also adapted the reflection API, and with reflection you can ask on a class who can permit it, so who can extend from it or implement it, or you can also see if a class is sealed or not. So let's have a look at how this works by diving into the code. So let's go back to our code block, and we have a sealed interface shape, permits a triangle. Then we have a sealed class triangle, which implements a shape, and then we have a final class square, which extends from the triangle. And let's write a simple test right here in a specific main method right here, and I'm going to create a triangle. Okay, and this triangle, I'm going to ask on the triangle its class, like this, get class, and I'm going to ask if it's sealed. So this is going to give me a true, because when you look at the triangle, it is sealed. And what you can also do is you can just from the triangle its class dot get permitted subclasses, and I'm just gonna print them out, permitted subclass, and this will give me all of the ones that are allowed to extend from this triangle. So we have the square here, so these are the mandatory permitted subclasses, and you can just access them via reflection. So these two have been added to the Java API, and this makes it very easy to see if it's a sealed class or who can actually implement it. So if you need this from reflection, they are available through these two methods. Of course, backwards compatibility is very important. New keywords have been introduced, the permits and the sealed keyword, and if you just write this piece of code, it still works. Or if you had something like this already in here, I'm just gonna add it to what we had. So the sealed and the permits keyword, they don't make any sense in this case. Okay, so Java compiler knows that the sealed keyword only can be used on a class or an interface, and when you already have it, it's not going to be an issue. So I can just write this, I can just safely upgrade to Java 17, and it should not cause any problems. So in general, we've seen sealed classes and interfaces, and it really allows you to control the implementation. We've seen the set of subclass rules with the final, the sealed, the non-sealed, and they are mandatory to add them. We've also seen the additional reflection API and how to use it, and a smarter instance of, so that the compiler can help you detect when a certain instance of is not needed or doesn't make any sense. I hope you've enjoyed the sealed API, and working with sealed is going to be so effective when you want to have tight or fine-grained control on how the implementation or extension of your classes in your frameworks can be done.